My name is Vaibhav Birukavnikar. Today I am explaining to TOC ISE. My roll number is 3143. My topic is Introduction to Turing Machine and Computing Function. A Turing Machine is an abstraction computational model used to define function and simulate algorithm. It consists of tape head, set of state and transition function that guide its action. TM are fundamentally understanding what functions are computable within this limit and formal computation. The defining function with Turing machine, a computational function with a TM involved designing the machine so that it holds with output on its tape. The TM reads the an input process it according to its a transition rule and produces a desired output. The process formalizes the concept of a function within the framework and automata theory. The problem of computing the n mod 3. The goal is to design Turing machine that takes an input representing non-negative integer n and outputs n mod 3. The type input typically encoded as a string of a symbol binary or unary. The challenges involve the machine that can perform division and remainder calculation. The construction of a Turing machine of n mod 3. The TM be designed to process the input by repeatedly subtracting the tracking the remainder using its state. It uses finite set of a state to represent possible limit 0, 1, 2, 3 or during the computational where when the input is fully processed the machine holds with symbol and indicating remainder on the tip. The summary this is computing the n mod 3 with TM demonstrate how abstract machines can perform the arithmetic function. The construction of the exemplify the broader capability of the Turing machine to compute the any computational function. Understanding the such essential theoretical computer computer science foundation computational function in which that can provide various functions.
Hello ma'am, myself Shantanu Jadhav. My roll number is 3144 and my IC topic is Universal Turing Machine and Encoding. So let's start with definition. A universal Turing machine is simulate any other Turing machines concepts. So input is encoding of a Turing machine in bracket m plus input string universal Turing machine execute m on w and giving output. Analogs like a computer running any program given on it. So importance basic stored programming concept in real computer prove that that single machine can perform any computation. So next slide is encoding functions. So purpose of encoding functions to represent a Turing machine inputs strings usually binary. So encoding functions is denoted by covered Turing machine description that states symbols transitions into Unicode. Let's see example. Suppose we have Turing machine M state Q0 and Q1 Q2 alphabets are 0 1 and b. So transition of q0 1 is q1 0 and r. So encoding example simplified q0 is equal to 0 0. So let's see example of encoding. So let Turing machine M is replace 1 with 0 and move right. So states are q0 and q1 input 1 and 0. So transition states are delta in bracket q0 and 1. So is equal to q1 q0 q1 0 and r. So encoding example q0 is equal to 0 0 in bracket q1 is equal to 0 1 in bracket 1 and 1 0 in bracket 0 1 1 in bracket r and 1 and equal to 1 in bracket l and equal to 0. So encoding transactions delta in bracket q0 1 is goes to q1 q0 q1 0 and r goes to 0 0 1 0 0 1 1 1 and 1. It goes to 1 0 0 0 1 0 0 0 1 0 0 1 1 1 1 is a part of an encoding of a Turing machine. Thank you.
Greetings everyone, my name is Bhageshwar Chauhan. Our roll number is 3145. Today I am going to present a essay activity for the subject TOC, and my topic is decidability properties of RL and CFL. So, what is decidability? A problem is decidable when there exists an algorithm which used to solve that problem, or that algorithm gives the value in the form of yes or no. So in that algorithm, that means our Turing machine, which accept that string if and gives the value in output in the form s. If the Turing machine does not accept that string, then it will use the answer in the form of no. So in that language is nothing but the our problem, which we are going to solve. We know that another topic is types of language. So we know that there is two types of languages. First is regular language, which is accepted by the finite automata, and second is the context-free language, so which is accepted by the push-down automata. That is which is recognized by the push-down automata. So here are some properties of decidability. That is membership property, emptiness property, finiteness property, equality property, subset property, universality property, and intersection emptiness property. So this property we are going to check for the language, that is that particular language is decidable or not. So we'll see one by one. Okay, so in table format we see that these properties are decidable for regular language or not, or context-free language or not. So in that first is the membership property. So membership property, that means the element is or a string is present in that language. That means L is for example, there is a string that is A which belongs to that language. So it is decidable for regular language and undecidable for context-free language. Second is the emptiness property. That means the given language does not contain any string. That means if we have two states, in that it accepts one as a string, but in second mode it does not accept any state. So it is decidable and it is undecidable. So emptiness property is decidable for the regular language and also decidable for the context-free language. Next is finiteness. In that the elements which are in the language is finite, or finite number of elements are in that language. So it is decidable for the regular language and decidable for the context-free language. Next will be equality property. That means both languages L1 and L2 are the equal. So it is decidable for regular language and undecidable for the context-free language. Next will be subset property. That means the all languages one language is a subset of another language. So it is decidable for the regular language and undecidable for the context-free language. Next is the universality problem. That means all the subset is present in the particular language. That means if the L1 is the universal set, in that it contains all the languages L1, L2, etc. Then intersection emptiness property. In that we intersect the two languages. In the result we does not get any 5. That means when we intersect two languages, it will use the value in the form of the 5. So it is decidable for the regular language and undecidable for the context-free language. Thank you.